Hello everyone, I hope you're doing well. So welcome back. I wanna address a very important short topic on fair games. And the work we've done lately on the arithmetic mean is all you need to figure out if a game is fair or unfair. You know, I'm very sure you've seen either on TV or on the streets of big cities like New York City or LA, where people on the side, play card games and, trade money, gamble money. And sometimes you wonder if the games that people are playing are fair. And I'm sure you can tell that they can't be fair because they wouldn't make money. But maybe you don't know why they're unfair. And I think it shouldn't be hard for you. In fact, you have all the ingredients, all the background and the knowledge to evaluate whether or not a game is fair. And the way it works is, number one, you need to know the rules of the game. Somebody want to play a game, you ask what are the rules, right? You always want to know the rules of the game. If you play basketball, you need to know the rules of the game. Otherwise, you're going to commit fouls. And then, based on the rules of the game, with your background, you can very quickly tell whether the game is fair or unfair. So I'm going to work out two examples, and then I'm going to give you, I'm going to let you create your own game, and I'll be very curious to what you might come up with. I might use your examples for future classes. I'm always interested in student perspective. So I look forward to reading the games that you're gonna come up with. So here is what I'm gonna start with. So imagine you have a dart board or whatever you want to call it, and it's split into three regions, and each region is assigned a dollar value. So you throw a dart, and if you hit this area representing a 90-degree angle, I put 90 outside. Usually we write 90 here, but I don't want to make the circle look messy. So I put all the angles outside, okay? So if you hit this region, you win $10. If you hit this slightly bigger region of 120 degrees, you win $12. And if you hit this region, which is even a little bigger than this one, you lose $16. And you might eyeball this and say, I think I'll play, or I don't think it's a good idea, right? But you can easily do the math to figure out whether or not you should play. Now, remember that I don't have to give you all three angles. I could just give you two of them. You should be able to know the third. If I give you these two, you should be able to know the third because you know that the sum of all the angles is 360, okay? So just like we did last time with tests, scores, and quizzes, and we associate with those their weights, 60% for tests and 30% for quizzes, we're going to do the same thing here to calculate the arithmetic mean, which we have done before. You did such a good job on the homework on this one. So, always your random variable and then the weights associated with that random variable. Make sure you always know what your random variable stands for. In our case, the random variable stands for the dollar amounts you will win or lose. So clearly, this random variable is a discrete, quantitative, of course. It's a discrete random variable. It stands for the dollar amount one would win or lose if they play this game. The associated weights, you can call it sometimes the percentage, the weights, the probability, the chance, call it whatever you want. For this one, the weights, see they carry different weights, see the areas are different, so they have different weights. So this weight is 90 out of 360, which is basically 1/4. Isn't that 1/4 of the circle? So this weight here is 25%. Isn't that true? So like a test is worth 60%, the weight to get $10 is 25%, or 90 out of 360. I like to keep everything out of 360 so it's easy for me to do the math. I know I can simplify this to and call it 1/4 or 25%, but it's better to keep the denominators the same. You can call it W1, the weight for the first X. This is X1, this is X2, this is X3. W1, you can call it P1. P1 means the first probability. Notice or remember, you should know this, that whether you're dealing with W, let's call it WI, or PI, it doesn't matter. That weight, that probability, that chance, that ratio, that percentage is always between 0 and 1. 0 means 0%. And 1 is 100%. Right? So the probability is always between 0 and 1. So this number is between 0 and 1. This number is between 0 and 1. This number is between 0 and 1. Inclusive, which means it is possible to have 0. It is possible to have 1. Right? The probability that you are watching this video right now is 100% because you are watching it. Okay, so you're here, right? The probability that you watched this video 2 days ago is 0%, right? So the probability is always between 0 and 1 inclusive. It is possible to have 0 and it is possible to have 1. Now, so how do we figure out the arithmetic mean or the average, the weighted mean, right? So we multiply x1 by the first weights plus the second x times the second weight and so on and so forth. Notice the second weight is 120 degrees divided by 360. It carries more weights than this one. And this one carries even more weights. It's 150 over 360. So this times this plus this times this plus this times this. That's all you need to do, okay? Now when you multiply fractions, you just go across. Let me put a 1 here so you don't get confused. Okay, so 10 times 90, which is 900, divided by 1 times 360, which is 360. Same thing here, this over 360, and this over 360. I added the fractions, it's 900 plus 1440, minus 2,400, you get negative 60, divided by 360. Please don't write 360 3 times, you just rewrite it once. And that number gave me negative 0.16 bar. And I put a dollar sign. So I'm going to pause here. So you know how to do all of this. This is just the weighted mean or the arithmetic mean. But I want to hit on the idea of expected value and a fair game. That's what we are about today. First of all, why the dollar amounts? Let's think about this. If you take a dollar amount, which is x1, and you multiply it by some percentage, you still get a dollar amount, don't you? For example, if I say to you, what's 25% of $20? You're going to say $5. You're not going to say 5, you're going to say $5. So a percentage of a dollar amount is a dollar amount. So this is a dollar amount. And that's a dollar amount, representing this. And that is a dollar amount, which is this, which is this. And a dollar amount plus a dollar amount minus a dollar amount is still a dollar amount. $5 plus $4 is $9, right? Therefore, the number that I got here is in dollars. That is the very first thing to realize. It's not tomatoes. It's not a percentage, because that probability has no unit, does it? Dollar times percentage is still a dollar. So this is in dollars. what does this mean? It means that if you play this game, you are expected to lose about 16 cents. So the very first thing you need to realize is this weighted mean or weighted average has another name called expected value. Basically, what it says, and you can tell, if you play this game, you are expected to lose between 16 and 17 cents. It's unfair game, but it's not bad at all. Nobody plays this game with you, okay? You'll always end up losing money. This is not much of a loss. It's still unfair because to make it fair, what should we get here? Pause the video and think about what number should you get to call this game a fair game. The answer is $0. If you just play, you're not paying or anything, you're just playing, you should expect nothing, right? So this is slightly unfair game. Whether it is plus 0.16 bar or minus 0.16 bar, it's not zero. Therefore, it is slightly an unfair game. How do you make it fair? You're expected to lose 16 cents. So whoever is playing this game with you, the owner of the game, should pay you slightly more than 16 cents. Pay you, okay? You don't pay, they pay you slightly more than 16 cents to play the game. Why? Because you are expected to lose 16 cents. Another way you could do it is play with these dollar amounts or these angles in measure so that when you recalculate this, you get zero, right? That's how you make it fair. So let's go to another example. It's a lot of gibberish here, but I'll summarize, okay? I just wrote it here so in case you want to read it at your leisure slowly. Very simple. Let's say you have a bag. You don't have a bag. The one who's playing the game, the one who's making the game, has a bag and has 20 chips in it, 10 and 4 and 3 and 2 and 1, 20 chips. Has one chip was worth $100, has two chips worth $20, has three chips worth $10, has four chips worth $5, and has 10 chips, which is basically half of the chips, number of chips. Total here is 20. So it has 10 chips, which is literally half of all the chips, worth $1. And all you need to do is they're going to shake the bag and you're going to insert your hand and pull one chip. Now you might be lucky and pull this one and you get $100. Or maybe you'll get $20 and there are two chances out of 20, right? But to play this game, they're asking you to pay $15. The question is, would you play the game? Sometimes it's not easy just to look and say, yeah, I think I can play, right? Now, for somebody who's so naive, they might say, oh my God, I'll pay 15 and I might get 100 or 20 and I have two chances for 20. I'm going to play. For a skeptic, he or she would say, oh my God, there are 10 chips out of 20 worth only $1. And there are 4 chips worth only $5. And there are 3 chips worth only $10. And they're asking me to pay $15? No way, I'm not playing. Now, both of those scenarios, the thinking is fine, but we want to be sure. Because your eye might trick you, right? Your eye might trick you. You might think it is unfair to you. It might be fair. It might be to your advantage, actually, right? So what do? Once again, we compute the weighted mean, otherwise known as the expected value. What do you expect to get by playing this game? What do you expect, okay? So previously, we had the random variable and we have the weights. For the previous problems we did last time on the tests and stuff, we had the number of points you got on those tests and quizzes, and the weights. And in here, I have my random variable, which we should define, and we're going to have the weights. You may wonder, why do we have this middle column? It is because I don't have just 100, 120, 110, 15, 11. I have a different configuration of each. Just like here, I only have one angle of 90, one angle of 150, one angle of 120, and therefore there was no need to create a column in the middle. Now I do. Last time we had one test, one quiz, one project. But if I had two projects, I may want to decide on the number of tests you're taking and number of quizzes you're taking. So you've got to do the counts here before you could figure out the weights. So we have the dollar amount. So what does X stand for? It stands for the dollar amounts one would expect to win. So it is a discrete quantitative random variable. Or just say a discrete random variable, because if it is discrete, it is already quantitative. It cannot be categorical. So this is the rules of the game. So this is what this person decided to do. Put 20 chips, put these number of chips, and these are the dollar amounts. That's the person's game. And wants you to pay $15 to play his or her game. And you want to know if it is fair to you. Now, what's the weights? Before we do the math, we've got to do the weights. So what's the weights? I want you to pause the video and figure out what should the weight for each of these be. It's not 1 out of 100, okay? So don't write 1 out of 100. So pause the video and think about the weight of each. If you are confused, go back here, figure out how did we do these weights, okay? So welcome back. So what's the weight for this one? Well, clearly you have one chip out of 20. So what should the weight be? It should be 1 out of 20. You have 1 out of 20 chance. You have 1 out of 20 chance or probability of getting $100. Doesn't that make sense? So please don't write 1 out of 100. You don't have 100 chips. You only have 20 chips. Okay? So the rest should be easy for you. You have 2 20s out of 20 chips. You have 2 out of 20 chance. Make sense? And here you have 3 out of 20 chance. And you have 4 out of 20 chance. And you have 10 out of 20 chance. Which should make sense. Because if you have 10 of the $1 bill out of 20, that's 50%. But if you had written 10 divided by 1, you're going to get 10. That's silly. These numbers should be between 0 and 1. And furthermore, they should, what? They have to be between 0 and 1, and they should add up to? They should add up to 1. If you add 1 out of 20, 1 divided by 20 plus 2 divided by 20 plus 3 divided by 20 plus 4 divided by 20 plus 10 divided by 20, you're going to get 20 divided by 20, which is 1. Okay? They always add up to 1, and each one of them has to be between 0 and 1. If you look back here, not only that these numbers are between 0 and 1, if you add these 3 fractions, I promise you, you will get 360 divided by 360, which is 1. Okay? So, now that we know the X value and the weights, we can find the expected value. What do we expect to win or lose? W1x1 plus W2x2 all the way to W5x5. I wrote WNXN, and in our case, n is 5. The last one is 5. W5x5. Okay? So, the first weight times the dollar amounts plus the second weight times the X value again, and so on and so forth, all the way to the last weight times the dollar amounts. When I multiply these, remember, when you multiply fractions, you go across. So there is a 1 here. So I'll just do the first one. 1 times 100 divided by 20 times 1. Okay, makes sense? So all of them will have 20 at the bottom, right? So I got 100 plus 40 plus 30 plus 20 plus 10, which is 200 over 20, which is $10. So now I want you to really pause the video. Notice I wrote $1, okay? I explained that to you before. So what I'd like you to do is answer these questions before we continue. Is this a fair game? Should you play it? How do you make it fair? If it's not fair, then of course you shouldn't play it. And if it's not fair, how do you make it fair? So please pause the video, take a couple of minutes, and think about this before we can continue. All right. So, is it a fair game? Don't just look at 0. Oh, we didn't get 0, it's not fair. No. The rule of the game is you pay $15. So you are paying $15 and you are expected to make $10. Would you play? Of course not. This is what you're expected to win. It's a win. It's not a loss here. And like this one, you are expected to lose 16 cents. And here you're expected to win $10. So just because this is positive, it doesn't mean that it is to your favor, to your advantage, because you are paying $15. Now, what is the expected value of $15? It's so easy and it looks weird. What do you expect out of 15? Well, X is 15 and the weight is 100%. So it's 15. You're definitely paying $15 if you play, right? So you don't have too many. You only have one of them. It's called 15. You are certain you're going to pay $15. So you're definitely paying $15, not expected. You are absolutely paying $15 if you choose to play. And you are expected to make $10. Definitely this is not a fair game. Should you play it? Of course not. Why would I spend 15 to make 10? So every game you play, you're expected to lose $5. So if you play 100 games, you are expected to lose $5 times 100 games. So you're expected to leave with a hole in your pockets. Okay? So you're expected to lose $5 every time you play, even one game. Now, why don't we say, notice what I do, make sure you listen to my words. I said you are definitely paying $15 with 100% certainty if you choose to play. I didn't say you are definitely winning $10. I said you are expected to win $10. You might be lucky and pull $100 or $20. You might be so unlucky and pull $1, but you're expected to win 10 by spending 15. So how would you make it a fair game? There are a couple of things you can do. For one, definitely shouldn't play anyway. But one thing you can do is go back to this guy who's playing this game with you and say, hey, I'll play this game if you drop this to $10. Because you're going to lose $10 and you're expected to win $10. That would be a fair game. So that's one way to do it. Hey, would you be willing to drop this to 10? If they say no, then you walk away. Another way is to say, okay, I'll pay you $15. However, I want you to change the rules. Maybe have more 20s, less 1s. Do it in such a way that when you compute this, you get 15. That would be fair, right? I can guarantee you, and I speak with certainty, that anytime you play a game at a casino or anywhere else, it is always unfair. It is always unfair, and it is always to the advantage of those who make the rules. So the moral of the story is you should never play. Unless you're playing for fun, you're not betting money, There is a difference between investing and gambling. This is gambling, okay? Now, if you play Monopoly with your family or you're playing with fake money, that's fine. You can play. You can decide if the game is fair. If it is fair, then play. If it's unfair, you don't play, even though it is a fake game. But to play this game, unfair game, with real money, you would have to be stupid, right? Especially you guys, because you know the math. So that means you really have to be stupid. Otherwise, I'll just call you naive, right? If you don't know anything, okay, you're naive. You got into the game. People pulled you, enticed you to play the game. And next time you are in a big city and you see people play a card game or something, go and stand there for a few seconds. And what they do is they have a bunch of friends who are pretending to be like you, like tourists, let's say. And they make them win over and over and again. And they keep handing them their $20 or $100 to entice you. They all know you are the tourist. They all know you are the stranger. They want to entice you to play so you can play. And then they know that the game is unfair, and then you leave with nothing. Okay? That's the moral of the story. So, to conclude this presentation, I was going to give you a problem or a game like I did before, but I thought, it'll be nice to let creativity shine, right? I'll let you come up with your own fair game. It has to be fair, okay? Come up with your own game that is fair. Show why is it fair by computing the expected value. I'm giving you a hint here, big hints. And I really want you to be creative. Don't just come up with something silly. I roll a coin. If I get a tail, you give me $1. If I get a head, you lose $1. That's silly, okay? I really want you to be creative and imaginative and write clearly, please write legibly or type. Write what game you have and what are the rules of the game, of course. And show me why is it fair by computing the expected value. And I said here, be detailed about your proposal and your strategy, okay? So please show the rules of the game, explain why is it fair, and make it fun. And I look forward to reading all of them. There should be 38 of them. So have fun with this little assignment. Take care.